It's not often that nature produces something as beautifully symmetrical as this. It's almost a perfect circle. But it's more than just a stunning piece of natural architecture, because deep down there are clues to some of the most dramatic events in Earth's history.
This wall seems to go down forever, and I'm told that the bottom here is 120 metres down, which sounds like a very, very long way just now, and I just drop it into the abyss. That shark just swam past in front of me. I've never ever been so close to a reef shark. And there's another two just behind me.
Finally, I've reached my goal.
So down here at 40 metres. It's really eerie, gloomy. And this is what I've come to see. And there's stalactites. But there's only one way I know of. The stalactites are formed. And it is down here to 40 metres of water, with sharks swimming about nearby.
Stalactites are created when mineral-rich water drips from the roof of a cave over hundreds or even thousands of years, leaving behind mineral deposits. In other words, they didn't form in the ocean.
Stalactites like this can only ever form above ground. And that means that when these grew, sea level was much, much lower than it is today.
Scientists have precisely dated stalactites from the blue hole. And by comparing these and other sea level indicators from around the world, they've built up a picture of changing sea levels dating back hundreds of thousands of years. It reveals a striking pattern. Sea levels across the world have risen and fallen over time.
Genuinely one of the eeriest things I've ever seen, that.
20,000 years ago, the entire surface of the world's oceans was 120 metres below where it is today. And that means if I was standing here 20,000 years ago, all of this, including the Blue Hole cave system, would be dry land. So where did the ocean go?
The answer is that it was on land, but it wasn't liquid water, it was ice, because 20,000 years ago our planet was in the middle of an ice age.
The Earth has experienced regular ice ages in a cycle going back several million years. These dramatic changes to the state of our planet are triggered by small changes in the Earth's orbit. I've travelled back to Britain to uncover the relationship between the Earth's orbit and an ice age. Snowdonia's peaks and valleys were carved out in the last ice age. It's in mountainous locations like this that an ice age would have begun, as snow gradually built up. When we think of ice ages, we think of extreme cold during the winter. But counterintuitively, it's summertime temperatures which are important in starting ice ages. And the reason for that is that now ice will build up here during the winter, but it will all melt away in the summer. But if the summer is a little bit cooler, a layer of ice will be left behind, and a series of cool summers will leave layer after layer, one on top of the other, building up, and here the ice could have been hundreds of meters high. Ice ages always start in the northern hemisphere because there's so much more land surface on which ice can build up. So the question is, what causes cooler summers in the northern hemisphere? The answer comes from small changes in the Earth's orbit, caused by the gravitational pull of other planets. Our orbit isn't exactly the same every time. Aspects of it change just slightly in cycles lasting thousands of years. And when all of those cycles reach their most extreme point all at the same time, that can change our summer temperatures just enough to tip us into an ice age. There are 3 cycles to do with the Earth's orbit that must all coincide to trigger an ice age. The first of these cyclical changes affects the time of year when perihelion occurs. This is the day when the Earth is closest to the Sun. Today, perihelion is in January, but over thousands of years the date of perihelion changes. When perihelion occurs in the northern hemisphere summer, it makes summers particularly hot. But when it occurs in winter, as it does today, then northern hemisphere summers are cooler. So at the moment, the perihelion cycle is at the right point to generate an ice age. But 2 other cycles are not in an ice age phase. The first is the angle of the Earth's tilt. The Earth's tilt is currently at an angle to the vertical of 23.4 degrees. But that angle changes between 22 and 24.5 degrees. It's only when the angle is at its shallowest, 22 degrees, that the seasons become less extreme and the summers cooler. Today, the angle of tilt is too great for an ice age. The final cycle affecting an ice age is the shape of the Earth's orbit. The Earth's orbit is an ellipse, but over time it becomes slightly more and then slightly less elliptical. When the orbit is at its most elliptical, the result is lower summer temperatures. At the moment, the Earth is midway through this cycle, so again it's not in an ice age phase. It's only when all 3 of these changes to the Earth's cycle line up together that they produce the really cool summers in the Northern Hemisphere that result in ice ages. At the moment, those 3 cycles are all at different positions, and so we're still getting enough sun during the summer to melt ice and keep us out of an ice age. It'll be around 60,000 years before the cycles line up again and the next ice age starts.